Hello guys, you are welcome back to this revision class. Now we are answering question 2 of June 2021 session. This question is divided into two sections, section 1 and section 2. We start with section 1. It reads, given that the roots of the quadratic equation x squared plus, in brackets, 2k plus 2 times x plus 2k plus 5 equal to 0 are alpha and beta. A. Find the values of the constant k for which alpha is equal to beta. B. For k greater than 0, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. Good. Before answering this question, let's recall this. We know that a quadratic equation is any equation of the form ax squared plus bx plus c equal to 0, where a, b, and c are elements of the set of real numbers with a not equal to 0. And we know that quadratic equations always have two roots. And these roots may be real and distinct. And if they are real and distinct, then the discriminant, which is b squared minus 4ac, will be strictly greater than 0. They may be equal. And if they are equal, the discriminant b squared minus 4ac will be equal to 0. They may be complex or imaginary. And in that case, the discriminant b squared minus 4ac will be strictly less than 0. But if the roots of a quadratic equation are said to be real, then there are two possibilities. Either they are real and distinct, or they are real and equal. And in that case, this is what we're going to obtain. The discriminant b squared minus 4ac will either be greater than 0 or it will be equal to 0. So in this particular question, we are told that the roots are alpha and beta, and that alpha is equal to beta. So that means that the discriminant is 0. It shows that the roots are equal. Therefore, for question A, we know that the discriminant b squared minus 4ac will be equal to 0. But what is our A? If we compare this equation with this one, we will notice that A is 1, B is 2k plus 2, and the C is 2k plus 5. And therefore, we know that b squared minus 4ac is equal to 0. Therefore, we have 2k plus 2 all squared minus 4 times 1 times c, which is 2k plus 5, will be equal to 0. So this implies that 4k squared plus 8k plus 4 minus 8k minus 20 must be equal to 0. So this implies that 4k squared, we know 8k minus 8k is 0, and 4 minus 20 is negative 16. So we have 4k squared minus 16 must be equal to 0. And if you divide both sides by 4, we're going to obtain k squared minus 4, which is equal to 0. And this is also a quadratic equation, which is the difference of two squares. So if you factorize this, we're going to obtain k minus 2 into k plus 2, which is equal to 0. And so if you solve for k, we are going to have k to be 2 or k to be negative 2. The second question says that for k greater than 0, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. Our two values of k are negative 2, and positive 2. So this question says for k greater than 0, meaning we have to take k to be 2. So for k equal to 2, this quadratic equation reduces to x squared plus, we know 2 times 2 is 4, 4 plus 2 is 6. So we have plus 6x plus 2 times 2 is 4 plus 5 is 9, which is equal to 0. And if you solve this quadratic equation, you are actually going to have two roots which are equal. The roots are negative 3 and negative 3. Good. So the second part of the question says we should find a quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. We know that the roots of this equation, as given at the beginning, were alpha and beta. So we know that the alpha plus beta normally is supposed to be negative b on a. Our a here is 1, our b is 6, and our c is 9. So this is equal to negative 6 on 1, which is negative 6. And alpha beta is c on a, which is equal to 9. Therefore, we need to find the sum of these new roots. These are the new roots here. We need to find the sum. And the sum is 2 alpha plus alpha beta plus 2 beta plus alpha beta, which is equal to, we have 2 into alpha plus beta plus 2 alpha beta. So this gives us 2 into, we know our alpha plus beta is negative 6 plus 2 into alpha beta is 9. So this gives us negative 12 plus 18, and this answer is 6. We also need to find the product of new roots, which is 2 alpha plus alpha beta into 2 beta plus alpha beta, which is equal to 4 alpha beta plus 2 alpha squared beta. That is, if we take 2 alpha times alpha beta, this is what we're going to obtain. Now, if we take alpha beta times 2 beta, we're going to obtain 2 alpha beta square plus, and if you take alpha beta times alpha beta, we're going to obtain alpha beta all this squared. So this is the same as, so if you look at all these terms, you discover that alpha beta is common. And if you factor out alpha beta, this is what we're going to obtain. Here we'll be left with 4 plus 2 alpha plus 2 beta plus alpha beta, which is equal to alpha beta into 4 plus 2 into alpha plus beta plus alpha beta, which is equal to, we know our alpha beta is 9. So this is equal to 9 into 4 plus 2 into alpha plus beta is negative 6. So we have negative 6 plus 9. So this is 9 into 4 minus 12 plus 9. We know 4 minus 12 is negative 8, and negative 8 plus 9 is 1. So 9 times 1 is just 9. So therefore, our quadratic equation can be written in the form x squared minus, we have sum of new roots, times x plus product of new roots, which is equal to 0. So this implies that x squared minus the sum of new roots is 6. So we have minus 6x plus the product of new roots is 9, which is equal to 0. So this is our new quadratic equation. There's a simpler method of solving for this quadratic equation. And in that method, we can simply solve this equation here completely. We know the roots are alpha and beta, and we know that the alpha and beta are the same. So we need to solve this quadratic equation completely. And if you solve that equation, this is what you are going to obtain. We know that x squared plus 6x plus 9 equal to 0 implies that we can use the factorization method. So we look for those factors of 9 that adds up to 6. And those factors of 9 are 3 and 3. So we can write this quadratic equation in the form x plus 3 into x plus 3, which is equal to 0. That is, x plus 3 square is 0, meaning that x is equal to negative 3. Therefore, alpha, which is the same as beta, is equal to negative 3. And so, the new roots are 2 alpha plus alpha beta, which is equal to 2 into negative 3 plus negative 3 times negative 3, which is equal to negative 6 plus 9, and this answer is 3. The other root is 2 beta plus alpha beta. That is 2 beta plus alpha beta, which is also equal to 2 times negative 3 plus negative 3 times negative 3, which is equal to negative 6 plus 9, and this is also equal to 3. So our new quadratic equation has roots 3 and 3. So the roots are also the same. And therefore, we can get the sum of new roots, which is just equal to 3 plus 3, and the answer is 6. And the product of new roots is 3 times 3, which is equal to 9. And therefore, the quadratic equation can be written in the form x squared minus sum of new roots times x plus product of new roots, which is equal to 0. So this implies that x squared minus 6x plus 9 is equal to 0, which is the same quadratic equation, which is the same as this quadratic equation here. So there are actually two methods. Now we get to the second part of the equation, which reads, find the range of values of x for which 2 minus x divided by x plus 1 is greater than or equal to 0. So what we need to do here is just to get the critical values and represent them on a number line and test the regions for which this expression will be greater than or equal to 0. And we know to get the critical values, you can equate 2 minus x to 0, and this implies that x is equal to 2. Secondly, if you equate x plus 1 to 0, we are going to have x to be equal to negative 1. So we need to represent these two values on the same number line. And when you represent these two values on the same number line, you discover that the number line is partitioned into 3. We have a region here, which is the region for values of x less than negative 1. And this region is the region for which x lies between negative 1 and 2. And this is the region for which x is greater than 2. And therefore, to test the region for which this expression is greater than or equal to 0, we need to pick one value from each region and substitute in this expression. And in this region, we can identify so many values. If we take a value, say negative 3, and substitute in this inequation, this is what we are going to obtain. If you substitute negative 3 in the numerator, we are going to obtain 2 minus negative 3, which is the same as 2 plus 3, and we know 2 plus 3 is 5. So that value will be positive. And if you substitute in the denominator, we are going to obtain negative 3 plus 1, which is negative 2. So in the denominator, we have a negative value. And if you take a positive value divided by a negative value, the result must be negative. In this region, we pick a value which lies between negative 1 and 2. Let's pick a value like 0. If you substitute 0 in the numerator, we're going to have 2 minus 0, which is positive. If you substitute 0 in the denominator, we're going to have 0 plus 1, which is also positive. And we know that a positive value divided by a positive value is also a positive value. And if you choose a number from this region, a number greater than 2, let's take a number, say 3 or 5, let's choose 5. If you substitute 5 in the numerator, we're going to obtain 2 minus 5, which is negative 3. So the sign, we're interested in the sign, which is negative. If you substitute 5 in the denominator, we're going to obtain 5 plus 1, which is 6, which is positive. And if you divide a negative number by a positive number, we're going to obtain a negative number. Now, at this point, we need to choose the region for which this expression is positive. And that region is the region between negative 2 and 1. And therefore, the set of values of x for which this expression is greater than or equal to 0 is simply the set x such that negative 1 is strictly less than x, which is less than or equal to 2. Strictly less than 1 because negative 1 is not in the domain of definition of this function. Remember, if you substitute negative 1 in this function, this expression will not make sense. So please, I will advise you to solve the questions and compare the two answers. And if you have any difficulty or doubts, you can leave your question in the comment section. Thanks so much for watching. In the next presentation, I'll be solving the third question, that is question 3.